So in case you are in need of a quick reviews in organic current actually circuits. So now here are the quick formulas for you to master in this case. So we have what we call the load mean square current given as I subscript RMS, that is the load mean square current, and this one is the same as having it as 0.7071 actually should be Imax. This is the maximum current, or should be a peak current. On the same note, Imax can also be given as should be root mean square current divided by 0.071. So take note of this. And on the same note as well, we also have another formula. By the way, let's have to look at this one as the equation 1. Let's say this is given as equation 2. So take note of that. And we also have the formula for the root mean voltage, and which is given as VRMS, and which is equal to 0.7. Now should be a 1 cell, should be just 7, and times the maximum voltage, which is given as that. Let's say this is equation number 3. And of course, if you may think of actually having should be Vmax here. We should have the Vmax in that case. So this is Vmax in that way. And even the Vmax can also be calculated as this as well. We just have to make it as a subject to so have Vmax, which can be given as VRMS divided by 0.071. Can be that. Let's say this is equation number 4. I think you're going to number these equations at your own time, or whenever you be following these actual equations, you just have to number them at your own time. And what is the formula for the average power? Let's say we have a circuit with a resistor R, let's say with a device with a load or device with a resistance given as R. So the average power given as B can also be given as should be the load mean square voltage times the resistance. So should be a square here. That is, this is the formula for the electric power. We can have it as this, or we can also use the Ohm's law, where we may think of having this one as well. Let's say we can also have it as this. Should be actually VRMS divided by, no, should be square divided by the resistance. And also we can use this one as well. That is should be RMS, should be that times VRMS, can be that. That's the formula for the average power. And how about the maximum power? We can also be able to have a maximum power. If that's the case, then we are going to use the maximum values. So maximum power will be given as, now have Imax squared times the resistance. Also have it as the Vmax squared divided by the resistance, and we can also have it as Imax times the Vmax. You'll be able to have the power that is the maximum power using that formula. So take note of that. And I should also have to familiarize yourselves with the formula for the inductive reactance. So what is the inductive reactance? So now this is given as XL. That is the symbol for the inductive reactance, and it is a part of the resistance as well as it is a part of the resistor, as it has got the units given as the ohms. So inductive reactance, it is the same as now the resistance. It is the same as that. and it is given as omega, which is angular velocity, times L, which is now inductance. So L is said to be inductance, and it is given in Henry. And angular velocity, it is given in Rad per second. But the overall SI unit for inductive reactance, it is given in ohms. So you have to understand about how you calculate the inductive reactance in that way. But what is the formula for the angular velocity, which is omega? We have it as 2 pi f, where f is the frequency given in hertz. So frequency is given in hertz. So it can be that we can have it is in a megahertz, but we should have to know how to convert that one into the basic unit, that is hertz. So take note of that. So that's how the inductive reactance can be calculated. If we have the inductance, if we have the angular speed, we can be able to have the inductive reactance using that formula. So that's the very important formula you have to understand as well, if that's the case. So how can you be able to have the current across the inductance in this case? So we use the Ohm's law. Let's say, for instance, root mean square current across the inductance will be given as V root mean square divided by the inductive reactance. This is according to the Ohm's law because this is also part of the resistance, as I have already highlighted this. So that's the formula we can use to have the current across the actual inductance. And likewise, we also have to calculate the voltage in some sort of. And what if we are looking for the maximum current, to have it as I max, that is equal to have V max divided by XL. So those are the things to have to understand about in that way. And I should also have to understand about capacitive reactance. So this is symbolized as XC. This is the capacitive reactance, and that holds the general, and it holds the general unit that is given in ohms. So this is also the part of the resistance. And what is the formula for the capacitive reactance? It is given as 1 over, no, should be omega times the capacitance. So this is the capacitance given in farad, and the omega, it is given in Rad per second, that is. And of course the overall units has to be given in has to be given in ohms. So X is equal to 1 over C times omega. So if we have the capacitive reactance, we can be able to have the capacitance if we have the omega. So that is. So how about the current across the capacitor? So now we have it as, let's say we're looking for the root mean square current, or have it as a V root mean square divided by XC. And likewise, if we're looking for the I max, so which means we'll have here max, we'll have max, that is. And if we want to have the voltage across a capacitor, you can also use the same formula, much as we have the root mean square current. So it can be that, but just have to familiarize yourselves with those formulas. That is the part of the analysis of the actually alternating current circuits. And what else should you have to be familiarize yourselves with? Now you have to understand about the impedance. Now this is for, let's say we should have to start with our RLC circuit. This is the circuit with resistance, inductance, as well as the capacitance. So how defined the total maximum voltage for our RLC circuit? So we have it as Vmax is equal to, now the square root of, that should be VR, that is the voltage across the resistor, and we have VL, that is the voltage across the inductor, minus VC, that is the voltage across the actually a capacitance, and over part 2 like that. So this is the formula that we use to have the overall maximum voltage. And likewise, if we are looking for the overall root mean voltage, we can also have it as V root mean square voltage is equal, where we have it in the same way, only that these voltages will be calculated using the root mean square concept. So bear that in mind. And how about the impedance? What would be the impedance of the circuit? And of course, before I go for the impedance, I should also have to write you another formula you can use to have the maximum voltage. So now the maximum voltage can also be given as, using the Ohm's law, that will be given as the Imax, and the times now should be what you call the R square plus now should be XL minus XC and over the part 2. So this is also another form you can use to have that of the maximum voltage. Likewise, if we're looking for the root mean voltage, can also be the same way, where we should have to understand about where we'll have to use this. So actually, where we'll have to express this one as the root mean actually a current. So take note of that. And how about if we are looking for the, let's say, maximum current, you have it as Imax is equal, now we'll have Vmax divided by this expression. So those are things you have to understand about in that case. And what is our impedance? So the impedance is symbolized as Z, which is equal to the square of now R square and the plus XL minus XC and over the part 2 like that. So this is the formula for the impedance, and it is given in octave ohms because it is part of the resistance. And from that perspective, it means Imax will be given as the Vmax divided by the impedance from the previous formula we have recently talked about. So in this case, the impedance is the same as that. And now, how about the phase angle? So now the phase angle is given as the theta is equal to tan inverse of, now should be that of VL, that is the voltage across the inductance, minus the voltage across the capacitance, and divide by the voltage across the resistance, should be that. Or else we can have it as the tan inverse of, now the formula for the voltage across the resistance we talked of, now having it as should be Vmax is equal to Imax times XL, and the voltage across the inductance should be a capacitance. We have it as Vmax, that is, now we'll have, this is actually VL, that is the voltage across the resistance, actually the voltage across the inductance, and we'll have this one as VC, the voltage across the capacitance, which is the same as Imax times XC. And of course, now if this is the case, then we can also use this one as well. Then this is also true, so which means we'll have it as should be a current max times XL minus a current max times XC divided by the voltage across the resistor, which is given as Imax times the resistance. This is according to the Ohm's law. And of course, if we are using the root mean square voltage, or should be whatever it means, instead of having Imax, we'll have it as I root mean square. I root mean square, and we'll have I root mean square. It is based on the definition that I've been given it about. And also another formula for the impedance can also be given as this. Another formula for impedance can also be given as this. That is the tan inverse of now XL minus XC divided by resistance. So this is also another formula for the impedance. You just have to mastermind about. So the angle can be negative or positive, whichever, but that's the formula. And how about the power factor? So what is the formula for the power factor? It should be, what is the formula for the average power in our AC circuit? So now the average power will now be given as I root mean square and the voltage root mean square times the cos of theta, where theta is the phase angle. And of course can also be given as this. That is I root mean square and to the power 2 times the resistance. So that's how the average power can also be calculated in that way. And also, but that is how the average power can be calculated in that case. And I also have to understand about the resonance frequency. So now the formula for the resonance frequency can be given as F subscript R is equal to 1 over 2 pi and times the square of LC, where this is the inductance and this is the capacitance. LC can also be given as, should be omega R, should be omega subscript R is equal to, now should be 1 over, now should be the square of LC. But what is the real principle behind this? You have to understand that if we tend to cross multiply here, or have frequency, resonance frequency in terms of the 2 pi, and of which this is the given as the omega. So since this is the resonance frequency, I'll have it as given as that. So which means this is the same as having it as this one. But that's the basic understanding of what is happening there. Because at first I said that the formula for the actually angular speed is given as 2 pi f. Now since we have the resonance frequency, which is given as 1 over 2 pi times the square of LC. Now upon having the cross multiplication, we'll have now 2 pi FR square of, now should be LC, which is equal to 1. So we'll have to divide everything by this one. We'll have this expression that will correspond to having it as, now we'll have the resonance angular actually a speed that will be given as that. So having the resonance angular speed is the same as having it as the resonance frequency. So bear that in mind. But the formula for the resonance frequency, and basically you have to understand about this one. That is 1 over 2 pi times the square of LC. Of course, we can use this. That is like that. In fact, if but this is the same as how you can have to make use of that one. But just that is fine. And what is the power factor? And the formula for power factor. So which means if we have the resonance frequency, we can be able to have, let's say, the inductance, and also if in that of a capacitance can also be obtained as well. And what is the power factor? This is given as the cos of theta. This is the actually, this is that of, it should be phase angle. So if we have the phase angle substitute here, we'll have the power factor. So that's how you have to understand about the analysis of the alternating current circuits in the basically mathematical point of view. Now let's try to go through some sort of questions and appreciate. So let's say this is the question. When an AC source is actually is connected across, should be 12 ohm resistor, should be 12 ohm. Now this is the resistance, that's the resistor which is given as the 12 ohm. The load mean square current, that is I RMS, is given as the 8 amps. Now question A says that find the load mean square voltage. So find the load mean square voltage across the resistor. So now simply we can just have to use the Ohm's law in this case. So we understand that root mean square current is equal to root mean square voltage divided by the resistance. So we have the resistor and load mean square current. We can be able to have that one. Using the Ohm's law. So take note of that. And what is the question B? Question B says that find the peak voltage, that is the maximum voltage. We are looking for Vmax. So we're looking for Vmax. Now since we have root mean square voltage, then we can be able to have a Vmax using this formula. That is V root mean square voltage is equal to 0.701, should be 0.7071 Vmax. So we can be able to have Vmax using that formula. And how about the question C? Now the question C is that what is the maximum current in the resistor? Now we are looking for a maximum current, that is Imax. So now since we have root mean square current, then we can be able to have Imax using the formula that says that root mean current, so should be root mean square current is equal to 0.0771, and that is Imax. So you'll be able to have the Imax using this formula. So now you can see what is a question D. Now the question D says that what is the average power? Now we're looking for the average power. Now we can use that of the average power is equal to root mean square current times the resistance, and whichever the formula for the electric power, only we are to use the parameters with the root mean square. If we are to go for the maximum power, it means we are to go for the maximum current, maximum voltage, some sort of. So now let's say this is the question. An inductor has a 54 ohm reactance, and when you connect it to, now we have inductive reactance, that is XL, we have it as 54 ohms. It should be 54 ohm. And when you connect it to 60 Hz source, the inductor is removed. Now we can see this is the initial frequency given as 60 Hz. So it should be that. Now the inductor is removed and then connected to 50 Hz. Now this is the, let's say, the final frequency given as the 50 Hz. That produces the load mean voltage, that is VRMS, which is given as the 100 watts. Now what is the maximum current in the inductor? We are looking for the Imax, and of which that will be given as Vmax divided by the XL. So we need to have the Vmax. What is the Vmax? So we have root mean voltage, we can be able to have the max using the formula that we already understand about. Root mean voltage is equal to 0.701, actually 71 Vmax. So try to have that and substitute it there. So which means the other parameters are of no use. So you can see how it works. So just have to ensure that you have properly highlighted the parameters, and you mastermind yourself about the formulas. Then you'll be able to work them out accordingly. Now let's go for the other questions you should have to appreciate as well. Let's say we have this question. An inductor is connected to an AC source power supplying a maximum output of, actually the maximum, that is Vmax, is equal to 4 watts at a frequency of, now we have the frequency given as 300 Hz. And what is the inductance? Now we're looking for the inductance, and having the root mean for the actually root mean square current, that is I Rm is be given as should be 2 milliamps. So what is mu times 10 to the power negative 3 amps. So keep that in mind. So how should you have the inductance if that's the case? You should have to understand that according to the given parameters, the concept behind the inductance will be expressed using this formula. That is, should be Imax is equal to Vmax divided by XL. So now, since we have a Vmax, we'll be able to have Imax since we have the root mean square current. So now, if we have Imax, we'll have it here, and also for XL. Upon having XL, we know that the formula for XL is given as the omega times the inductance. So which means the omega is given as the 2 pi f. You'll be able to have to solve for inductance in that way. So now you know what is happening there. And finally, let's have to appreciate this question. It's actually a series AC circuit contains a resistor, an inductor. So which means, so it contains the resistor, an inductor, and also a capacitance. So it should be a capacitor, so that is given as that. So a source with, now we have, now what are the given parameters? We have the resistance that we do not know, and we have the inductance, which is given as 150 times 10 to the power negative 3 Henry, and we have the capacitance, which is given as 5 times 10 to the power negative 3 Farad, and we have the Vmax, which is given as 240 watts, and we have the frequency, which is given as 50 Hz, and we have the maximum current, which is given as the Imax, which is given as, now should be 100 times 10 to the power negative 3 amps. So that is, so the question, the first question says that we should have to calculate the inductive reactance, that is given as XL is equal omega times the inductance. So the omega is calculated as having 2 pi f. So we have the frequency, we'll be able to have the XL there. So that's how we'll have the first part of the question. So what is the second part of the question? Try to ask is actually is trying to ask about. So the other part says that find the capacitive reactance. Now principle remains the same. We're looking for XC, which is 1 over omega times, now should be a capacitance. So you'll be able to have that and out at your own. And how about the other part? The other part says that we should have to calculate. Now we're looking for the impedance. So I understand that the impedance, which is given as Z, according to the formula we discussed, it is given as resistor R should be that plus now XL minus XC to the power 2. This is the formula of the impedance that we discussed about. On the same note, we also says that the impedance is also equal to, now should be Vmax divided by, now should be this. So because we do not have the resistance, then this formula will not work. So how else should we have to think it about? So we should also have to think about this one as well. So we discuss about the formula for the impedance that says that Imax is equal Vmax divided by the impedance. This is what we discussed about. So we'll be able to have the impedance using this formula, much as we have all these things. Then what is the other part of the question? Now it says that we should have to calculate, now should be the resistance in the circuit. So which means now we'll go back to the formula for the impedance that says that the square of R square plus XL minus XC over the part 2. So since we have this, in this 2 we have them, then we'll be able to have the resistance in that way. So take note of that. In the final part it says that what is the phase angle. So you know what is the phase angle there. So the phase angle will be given as, now which formula will help us to have the phase angle? So try to think of the formulas we discussed about, and with respect to the parameters that we have, and see which one is the best method used to have the phase angle. So here is another actually question as well. At what frequency does the inductive reactance of, should be that equal to the capacitive reactance of, so it should be that. So now we are looking for actually a resonance frequency given us should be FR, so which is given as 1 over 2 pi the square of RC. So now since we have the capacitance and also should be we have the inductance as well as the capacitors, you can be able to have the frequency using this formula. And also here is another question. So an RLC circuit consists of, now this is, so should be, what's happening here? This has to be ohms. So 150 ohm resistor. Now this is the resistor which is given as 150 ohms. And a capacitance which is given as 21 times 10 to the power negative 3 farad. And the inductance which is given as, now should be 460 times 10 to the power negative 3 Henry. And we have, now should be the frequency which is given as should be 60 Hertz. So should be that 60 Hertz, like that. And we're sure that it is connected in series with 120 volts. That is the maximum voltage. That is 150 volts. So that is the voltage from the source, which is of a maximum. So it can be that. So what is the phase angle between the current as well as the upright voltage? So we're looking for the phase angle in this case. So how should you be able to have the phase angle? So we need to have it as angle theta is equal to tan inverse of, now should be XL minus XC to the power 2 into overall divided by the resistance. So we need to have XL, XC, and that should be that. So we can be able to have XL as well as the XC using the information that we have. Try to properly look over that one. So that's how you have to understand about the quick reviews I had for you on the alternating current circuits. So just have to go through some related questions, and you'll be able to be actually at least be in line with the concept. Thank you, but don't forget to subscribe to have, for you to be having more updates on whatever I'm going to upload, and that is good for you. Thank you.